Hello viewers, are you ready for this journey? It's going to be an exciting journey. Now, we want to look at some of the parameters I've used in chemistry titration. A lot of students have, even teachers, have problem when it comes to parameters used in titration. But in this video, I want to use the 2025 chemistry practical, the one, the exam they just wrote, to calculate all these parameters. Now we have different set of parameters here. Look at different set of parameters here. Now in 2025 YA chemistry practical, these are the questions that have been given. This one that is for titration. You see, A was prepared by what? Dissolving 0.825 grams of what? HCl in 25 cm cube of what? Of water. B contains 4.0 grams of impure sodium hydrogen triacylcarbonate per 250 cm cube of what? Solution. You are asked to put A in the burette and titrate it against what? 20 or 25 cm cube of portion of what? Of B, using methyl orange as what? Indicator, given the question here. And after that, you have a concordant value, titer value. And the endpoint we use in the YA 2025 chemistry practical was what? 23. That volume of A is equals to what? 23.50 cm cube. So our volume of, without drawing the table, I just want to use this average volume of acid to calculate the parameters. Is that understood? So we'll look, VA will take our average volume after you have drawn your table. That is first titer, second titer, third titer, initial, final, and the volume of acid. After that, you get the average volume of acid, and at the end we have our what? 23.50 cm cubed. We are asked, you see, from your result and the information provided, calculate one, concentration of what? Concentration of solution A in moles per dm cubed, concentration of solution B in moles per dm cubed, concentration of solution B in grams per dm cubed, percentage of what? Purity. This is where these four items you are asked to calculate in YA, the YA that just passed. Okay, 2025 YA that just passed. You are given 1, 2, 3, 4 to calculate, but we want to use this particular question to calculate volume of carbon dioxide at STP. If you look at this question, this acid salt react with this acid to form what? Sodium chloride and carbon dioxide. Oh, sorry. Carbon dioxide is liberated at the cost of the equation. So we are asked to calculate the volume of carbon dioxide at STP. Is that understood? The amount of sodium ion in 1 dm cube of what? B. If you look at this same salt, sodium ion, there is sodium here, so we are asked to calculate sodium ion. We are also asked to calculate the amount of solution A. These three things are added so that in subsequent calculation you know how to calculate these three things, but we are going to look at this one extensively. So if you are watching for the first time, this is on my YouTube channel. What you have to do is hit that subscription button. Just subscribe. It doesn't take you anything to subscribe. Is that understood? Now be patiently wait and see how I'm going to solve this thing. It's very, very simple. If I show you how to solve this thing, you will not even read any textbook and before solving any chemistry practical question when it comes to titration. So take a look at this question, because I'm going to wipe the board and use it and calculate. Is that understood? I'm going to wipe the board and use it and calculate. The question, we are going to, each one that we calculate, we wipe it. So we have given this one. What you should know, I've just written since I wiped the board, I've just written A is what? 0.825 grams per what? Cm cubed, or what? HCl. Why B is this? Now, when you are asked to calculate solution A in moles per dm cubed and solution B in moles per dm cubed, I told you that the formula you can use to calculate concentration in moles per dm cubed, there are two. One is, we have one, molar concentration is equals to mass concentration over molar mass. That is one of the formula. Second formula, 2, CAVA all over CbVb is equals to Na all over Nb. This is the first formula and this is what second formula. Now both of the formula will be used because none of the concentration is given in moles per dm cube. If in the question here no concentration is given in moles per dm cube, if they give you one of the concentration in moles per dm cube, you go direct and use this formula. You don't need to use this one. Go and use this one. But if they didn't give you any of the concentration like in the case of this one now, they did not give us all concentration here are in what? In grams per dm cube. So you go direct and use this one first before using this one. So we are going to use this one. Use this one to calculate number one. It says concentration of A in moles per dm cube. So our formula is molar concentration equals to mass concentration all over what? Molar mass. Now mass concentration is expressed. Mass con is expressed in grams per what? Dm cubes. But here the concentration is what? Expressed in what? Gram per what? Cm cube. So we need to change this concentration from per cm cube to what? To dm, to grams per what? Dm cube. So how do we do that? You say but mass con is equals to what is given here. Remember you are looking at A, so everything will be of A is 0.825. you multiply by 1000, you divide it by what? Divide by 250. 250 is equals to what do you have? You have 0.825 multiplied by 1000 divided by 250 is equals to, so you have 3.3 grams per what? Dm cubed. On no account should you work with what? Per cm cubed. Always change it to what? Per dm cubed. So this is how to change it. Is that understood? Now having looked at our mass concentration, what is our molar mass? A is what? HCl, and molar mass of HCl is equals to what? 36.5. Hydrogen is 1, chlorine is 35.5. Do you get that? So 1 plus 35.5 will give us what? 36.5. Then we now go back to our formula. Molar concentration is equals to what? What is our mass concentration? We have it as what? 3.13 divided by what is our molar mass? This is our molar mass, 36.5. So the answer will be equals to what? Divide that one by what? 36.5 is equals to, so we have 0.090 moles per what? Per dm cubed. Moles per what? Dm cubed. So this is our first answer for this question. If you don't have this answer in your WAEC, it means that you are wrong. So this is our answer, 0.090 moles per what? Per dm cubed. Is that understood? Take a look at it while we proceed to the next one. Now go to the next one. The concentration of solution B in moles per dm cubed. Since we have already used this one to calculate of the one of A, we are going to use the second one to calculate the one of what? Of B. Simple. So having done that, we say that we now go. Okay, we now write our A down. A is equals to 0.090 mole per what? Per dm cubed. Let's go. So we say we are going to use the second formula. The second formula say that this is the one of I and now I. It say CAVA all over CBVB is equals to what? NA all over what? NB. Now you are looking for what? CB. Remember, concentration in this one must be in moles per dm cube, not grams per dm cube. So this one you are going to get the value of moles per dm cube, the one of what moles per dm cube. Is that understood? So now you are asked to calculate concentration of what B in moles per dm cube. So you make CB the subject formula. CB now will be equals to, when you take this one from here, you cross this one, that will cross multiply. So this one now and this one, you are removing this one, so this one will be on top. CAVANB all over VB is equals to what? NE. Sorry, NE. Is that understood? So your CB is equals to what? What is your concentration of acid? Remember, concentration here, I've told you that is expressed in what? In moles per dm cube. This is your concentration. You take it 0.090. Multiplier. What is your volume of acid? I told you that VA is equals to what? 23.50. That is the one you have as your endpoint. You get that as your endpoint. So you have 23.50. You multiply by, what is the mole ratio? Mole ratio, remember the equation they gave you is NaHCO3 plus HCl will give you what? Will give you NaCl plus CO2 plus H2O. Is that understood? So now what you have to do is that the mole ratio is what is outside there and what is outside here. Nothing is outside here. You are looking at acid is to base. So acid here is, nothing is here, so it's 1. Base here, sorry, acid here, nothing is here, is what? 1. If that you have 2 here, there are 2 in front here, it would have been 2:1. If here, nothing here, so you put it as what? Here, nothing here is what? 1. So our mole ratio is what? 1. So you divide it by what? Divide by, what is our volume of base? Volume of base is that prepare you saw, which was given as what? 25 point. So you use a 20% 20.0 cm cube or 25.0 cm cube, but the one we normally use in the laboratory is 25.0 cm cube. So now we have 25 times what? Times mole ratio for acid. What do you have here? Is 1. You get that? So CB now will be equals to, we multiply this one 0.090 multiplied by what? 23.50 is equals to, you have what? The answer is 2.115 divided by what? 25. Is that understood? So at the end, divided by 25 is equals to, you have your CB. Your CB as what? As 0.085. You are approximating moles per what? Per dm cube. How do you see? It's very simple. So our CB now, that is B now is equals to what? That's, we have 0.085 moles per what? Per dm cubes. Hey, that is how you are supposed to have. Is why you get to what? To have. So if your school don't have it like that, maybe it could be due to endpoint, you have variation, but the calculation remain what? Remain the same. That is how you are supposed to calculate it. The formula that you are going to use is, you say percentage purity is equals to mass concentration of pure, percentage purity of what? Of what? Of this one, of base. Mass concentration of pure NaHCO3 divided by mass concentration of impure NaHCO3 to multiply by what? By 100. Percentage is always times of 100. This is the formula you are going to use. Now, what students used to get confused is that which one is your concentration concentration of pure and concentration of what? Impure. Remember, all of them are what? Mass cons. You get that? Now, concentration, mass concentration of pure acid. Listen, mass concentration of pure acid is the one that you calculate. Is the one that you calculate using this formula. Using this formula, mass concentration is equals to molar concentration times what? Molar mass. So the one you calculate is the one of what? Pure. Pure. Do you get that? Why impure is the one that is given in the question. Is the one impure. Okay. Question given in question, given in the question. Given in the question. Which one is given? Look at the one that is given in the question. Look at it. Look at it here. Have you seen? Look at the one given in the question here, and look at the one that we got here as our calculation. So this one is your pure, while this one that is given in the question is your what? You are impure. Do you understand? So we have calculated our impure. That is it, we have calculated our pure. This is, we had what? 7.14. Do you get that? Why the impure is what? Is the one that is given here, and it's given in what? 4.0 grams. 4.0 grams per what? CMQ. And I told you that you don't express mass concentration in CMQ. You express mass concentration in what? In grams per gen. So we need to change this one into what? Grams per what? CMQ. So it's a percentage purity. Percentage purity is equal to mass concentration of pure. What do we have? We have 7.7. No, you say that, but you say mass conc of pure is equals to what? 7.4 grams per what? DMQ. Mass conc of impure is equals to, we have 4 times, we are going to change this CMQ into what? Into DMQ. You multiply by what? 1000. You divide by what? The CMQ 250. So that we now have our impure. So 4 times 1000, that is 4000 divided by 250 is equals to, so we have 16 equals to what? 16 grams per what? DMQ. Is that understood? Therefore, are you following? Very, very simple. So therefore, we now go and work. So percentage of purity now, purity is equals to mass conc of our pure. We have 7.14 divided by of the one of impure 16. You multiply by what? 100. So percentage of purity. Oh my God, this thing is simple, man. We have 7.14 divided by what? 16 is equals to, we have 0.04. Okay, let's 6 times 100. Okay, so times 100. So at the end, we have our percentage of purity as well. Is equals to 44.6%. 44.6%. So if your school didn't have this one at the cost of calculation, there is something wrong. So this is what you are asked to calculate in YA question 1. So we have just finished solving that. So now let's go to other one. Volume of carbon dioxide at what? Liberated at what? STP. Volume of what? NaHCO3 plus HCl will give you what? NaCl plus CO2 plus H2O. This is the equation of reaction. Now, to calculate volume of carbon dioxide, you will see that 1 mole of NaHCO3 will give you what? 1 mole of CO2. Where are the mole coming from? Here, what is here in front of here? Nothing is there. If that there are two, you would have said 2 moles. So this is there is nothing here, you say 1 mole. What is in front of carbon dioxide? Remember, this thing, this particular salt is the one that is carbon dioxide is coming from, not from acid. There is no carbon here in acid. So carbon dioxide is coming from this equation. So 1 mole of this one will give you what? 1 mole of carbon dioxide. Do you get that? But you now say that 1 mole of NaHCO3 will give you what? Will give you 22.4 dm cubed or what? Of CO2. 1 mole of this will give you 20 because the volume of carbon dioxide at STP is what? 22.4. The volume of carbon dioxide at STP is what? 22.4. Then the mole of this one is what? What is the mole of this one? You are going to use the value of molar concentration. What's the value of molar concentration of B? Look at it here. The value of molar concentration of B. Do you get that? So you now say 0.085 mole of NaHCO3 will give you what? 22.4 of what? Of CO2. Therefore, volume now will now be 0.085 multiplied by what? 22.4. Oh my God, this is simple, man. 0.85 times 22.4 is equals to, at the end you have your what? Volume of carbon dioxide 1.904 dm cubed. Oh my God, it's simple, man. It's simple. So now this is what anytime you are asked to calculate volume of carbon dioxide, that is the formula. Anytime you are asked to calculate volume of carbon dioxide, that is what? The formula. Now let's go to this one. Mass of sodium ion in 1 dm cubed of what? B. Mass of sodium ion in 1 dm cubed of what? B. Now, sodium ion, from the equation, the sodium ion is coming from this one. Sodium ion. So mass of sodium ion, say mass of Na plus in what? In 1.0 dm cubed. Remember, to calculate mass, okay, mass is given as what? Molar mass times what? Times molarity, molar concentration. Do you get that? Now, what is the mass of sodium ion? What is the molar mass of sodium ion? That is atomic mass of sodium ion. Sodium is what? Na. Na is equals to what? 23. That is the atomic mass of sodium ion. Therefore, the molar mass will now be what? So just take note of that, okay? So the molar mass will now, the mass now will now be what? Mass is equals to, this is the formula to calculate mass. That is, we now have the molar mass, so we have 23 times what's the molar concentration? This sodium ion is coming from where? Sodium is coming from this compound. So what is the molar concentration of this compound? Look at it here. Is that understood? Oh God, it's simple. So you have 0.085. So you have 23 times what? 0.085 is equals to, so you have mass is equals to what? 1.955 grams. Remember, mass is measured in gram. What a unit of mass is what? Gram. So that is how to, anytime you are asked to calculate mass of this in 1 dm cubed, this is how to calculate it. Is that understood? Now, amount of solution A. How do you calculate the amount of solution A? These are parameters. There are about 14 parameters you need to know in chemistry practical. When you know this 18, no question in chemistry titration that you not be able to tackle. So we are going to calculate the last one. Let's wipe this side. Wipe this side. So amount, how do you calculate your amount? You say amount is equals to molarity or molar concentration times what? Times volume. Oh my god. Times what? Times volume. The molar you say A is what? Our A is what? Of acid. Do you get that? So molar concentration of acid is given as what? 0.1090. Do you get that? And the volume of acid is what? Va is what? 23.15 cm cubed. Is that understood? So now say amount is equal to molar concentration is what? We have 0.090. Why we are using that one? Because it's the amount of what? Of solution A. And what is our solution A? Solution A is acid. You get that? Solution A is what? Acid. Times what? Times volume. Our volume is what? 23.150. Sorry. Now, but remember, the volume here is in what? In cm. We need to convert this volume into what? Into dm cubed. Do you get that? Because you are going to solve it using dm cubed, not cm cubed. So you have to divide this volume by what? 1000 to convert it into what? Into dm cubed. Amount now is equal to 0.090 multiplied by what? 23.50 divided by what? 1000 is equals to, we have 0.0235. So times 0.090 is equals to, so amount of solution A now is equals to 2.11. Okay, this one is in 2.1 times 10 raised to power minus 3. I think that's what is given there. So this is how to calculate your parameter. In our next video, if you are watching it for the first time, just subscribe, please. The only way you can support me is by what? Subscribing. If you have not subscribed before, just subscribe. If you find this video useful and helpful, please share to anybody that is writing WAEC or NECO. Remember, NECO is coming by very, very soon. So for all SS1, SS2, you need this video so that you can be able to prepare yourself against next year what? WAEC. Thank you very much for watching. Have a blessed day. Bye bye. I love you.